Hello everyone and welcome back. In this video we will understand asymmetric SUOTA and perform the asymmetric SUOTA update for the DA14592 SoC. But before we begin, let's first take a look at the DA1459 family. The details about SUOTA can be found in the DA1459 Software Platform Reference Manual from here. And on that page, scroll down to the design and development part. Here you can find the SDK, this one, which you will need to try SUOTA with the provided example projects. First, let's understand what is asymmetric SUOTA. Asymmetric SUOTA uses two image banks that are different in both size and functionality. The main application bank has a large flash region that stores the full application firmware, which runs during normal device operation. While the SUOTA updater bank has a much smaller flash region that stores a minimal firmware. This lightweight firmware only provides the SUOTA service and is the only one capable of performing software updates. Now let's visualize the asymmetric SUOTA flow. After the production, this is the first image. Then the asymmetric SUOTA image becomes the active image. Then the application image gets written to the partition. Once this image gets written completely, the device reboots and the active image address gets updated to this image bank. The size of image banks in the flash layout would be updated by the application we will use, that would be asymmetric SUOTA application. Now let's go through the steps of how an asymmetric SUOTA image can be updated through asymmetric SUOTA firmware. This is the flash layout after initial programming of asymmetric SUOTA. Then the asymmetric SUOTA image gets running. Then new asymmetric SUOTA image gets written to the application firmware partition. After reboot, the new asymmetric SUOTA image gets copied to the asymmetric SUOTA image partition here. The address of active firmware image gets temporarily updated to the SUOTA image partition. Here we can see right now we do not have any application image. Finally, the application image gets written in the application firmware partition. And then on reboot, active firmware address gets updated to application firmware image. Now let's see in practice how to prepare the asymmetric SUOTA image. Import the asymmetric SUOTA application, BLE advertisement application and Python scripts. Select toolchain to version 7 and the target device. As the first step, we will erase the existing memory using the erase eflash script from here. Connect your DA14592 device with your laptop and run this script. Give the required options here and let the script execute completely. Now build the asymmetric SUOTA application using the debug eflash SUOTA option. After it has completely built, now build BLE advertisement application. with the Debug eFlash SUOTA Asymmetric option. So both binaries are now compiled. Now load the asymmetric SUOTA binary to DA14592 device. Run this application, and after this, in the same way, we will run the BLE advertisement application. Run the application here and then terminate the debugging mode. In addition to the application binaries, BLE Advertiser demo application also creates an image. Which you can see here. This is a SUOTA image containing the asymmetric SUOTA. We will place this image on our Android or iOS phone in the SUOTA directory available in the internal storage of our mobiles. So now connect your mobile to the PC where you are working and copy the image. This is the SUOTA directory where we will copy our image. And place it in here. And now you can disconnect your mobile from your PC. After downloading both applications, Asymmetric SUOTA and BLE Advertiser binary, press the K2 button on the development kit board. The BLE Advertiser application should start running. Now launch the Renesas SUOTA application on the Android phone. And select the DA14592 device that you want to update. Select Switch to SUOTA mode. Wait for the device to reboot in SUOTA mode and connect. Select Update device. Select the appropriate image file. In our case, we have BLE Advertiser image. Here we have some parameters for sending the image through SPI interface like the GPIOs used for MOSI, MISO, clock and slave select. And for the I2C, we have slave select address, clock line GPIO and data line GPIO. And from here we can select the block size of uploading the image. Now touch Send to Device on the touchscreen and wait until the process is completed. The image will be uploaded when the Renesas box pops up asking for a device reboot. So we have to select OK for this so that the new software image gets uploaded. Press close to return to the main menu. And that's it. We have successfully sent a software update OTA using the asymmetric SUOTA. Thanks for watching.